All right, so in this video here, we're going to be reviewing for your midterm 1, and this is the third of a set of 4 videos, and we're going to be reviewing chapter 3 in this video here. So there weren't any extra questions here. They just wanted us to look at some book questions. So I'm just going to jump right into some of the book questions here. Okay, so chapter 3 has quite a few questions. And I'm going to show you a couple things on the 84 as well that can help you here. Okay, so I don't want this video to be too super long. It's going to be probably a good 20 to 30 minutes, but I don't want it to be longer than that. So I might skip a couple of the questions and just do ones that I think are going to be good for us here. Okay, so on question 3.9, it gives us this really small data set here. Okay, and if you wanted to find the mean, the way you're going to do that is add them all up and divide by n, where n is 1, 2, 3, 4, 5, 6. N is 8 data points. Okay, so how I would do that here is I would do 5 plus -7 plus 2 plus 0 plus -9, 16, 10, and 7. And I would divide that by 8 and I would get 3. So let's write that. 24 over 8 gives me 3. Now, if I wanted to find the median, I'm going to order these from least to greatest, including the negatives. Which isn't so bad when you have this small data set of about 8 digits, okay? And the median is going to divide the data set in half. So there's going to be 4 data set pieces in each half. Now, when the median isn't an exact number, you're going to average 2 and 5. So 2 plus 5 over 2 gives me a median of 3.5. And then mode means the most, and there's actually none here. Now, that's all fine and dandy, but also your calculator will do a lot of this heavy lifting for you. Now, the expectation is that you still show work. Okay, I'm going to say it one more time. The expectation is still that you show work, but you can also check your work by doing something really good here, okay? So let me show you how to do this on the 84. So what you're going to do is you're going to press the stat button, which is right here, okay? You're going to go under edit and you're going to put this data in list 1, okay? And it should give you 9 as the next one because there's 8 data points. So you have data points in that and it's like, what's your 9th entry? Well, we don't have one, okay? And then you're going to press second and quit to get out of that. Okay, second and quit to get out of that. And your calculator, you're going to ask it to find this information for you. So if you go under stat and go over to calculate, one variable statistics. Now it automatically assumes L1, but let's just say you didn't, you put it in L3. I don't know. You can press the second button and then you can see the list names here. So L1 here, okay? But again, if you didn't do that, it would give you the same thing. It assumes L1. Now look, X bar, that's your mean 3. That's what we got here. So it does that for you. Also notice it has a little down arrow. There's more data here. Okay, there's N is to 8. We did that. And look, it told you the median here. Now notice when we put in the list, right? I didn't put it in order, but the calculator still found the median for me. Okay, so it can do all of this work for you, and you can use it to check your work. Again, you must show work on the test. I'm not giving you a magical shortcut, okay? I'm showing you a way that you can show your work, okay? So again, for the mean here, let's just show our work here. We're going to add these all up. So 127, 82, 45, 99, 153. Sorry, transitioning over here. 32, 61, 77, 108, 68, and 278. Now this data here is bonuses, and they're in thousands. So that's why I was like, wow, because this would be like $3 million, because it's 3,261 1,000. So that's pretty amazing. That person made that much money. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So in this case, n is equal to 10. So when I divide my sum here by 10, I get 429.98 divided by 10 gives me 429.8. In order to find the median, I would need to put these in order. So I would start with 45, and I would end with 3261. Now remember, n, if it's 10, it's going to be somewhere in between the 5th and the 6th term, okay? But I can kind of show some work here and then go to my calculator. And if I want to get rid of this list, you press up to highlight. I don't know why this is just how you do it. You press up to highlight, clear, enter, and it will clear it out. Up to highlight, clear, and enter. And I can plug this in really quickly. Okay. And we can check, yes, our mean is correct. And our median is going to be 103.5. Mode, there is no mode because there is nothing that repeats. Okay. Now the 10% trimmed mean. On the 10% trimmed mean, I need to take out some of the data values in order to find this 10% trimmed mean. Okay, so what I'm going to do is I'm going to take 10% of n. So 10%, 0.1 times n gives me 1. I need to take one data value off of this data set. So that would be the smallest value and the biggest value. Or if I go back up to my unordered list, it would be these two values right here. And now I'm going to find the mean from there. So 127 plus 82 plus 99, 153.77, 108, 68, and 278. Now I am dividing this by 8 this time because I only have 8 data points. And that gives me 124. Now this is in dollars, all of this here. Now why did this decrease by so much? If I had a mean of $430,000, and when I take out these two values, I now have a trimmed mean of 124. And the reason is this one huge number has such a huge weight on the mean, okay, that it's pulling it towards that large value. And that's why the trimmed mean can help us, because it kind of allows us to get rid of anything extreme on the ends, okay, and allows us to really zone in on what's important in the middle. And so this is probably actually a better estimate for the average number of bonuses because it doesn't include that huge value there. Okay. All right, now when I'm looking at 317, I'm already like, oh my gosh, I don't want to have to number this. I don't have to go through all of this. Okay, so let's just go ahead and use that list in spreadsheets function here. Okay, so if I go under this list, again, to clear this out, I'm going to go up, clear, enter. And I'm going to take some time here to put these 20 data values in. And it doesn't matter if you prefer going down the column or going across the rows. As long as you have the data values in there, it doesn't matter, y'all. Okay. Okay, you just have to have 20 data points here. And if you're like, but it says 21. No, that's the blank one. That's the one you're on, so you would have 20 data values here. Okay, so stat, calculate for me these statistics here. Now, one of the things that it does do for you is you see this little sum of the x's here? A little sum of the x's. that gives you, if you were to have sat there and been like 23 plus that's it right there, okay? And then remember, I'm going to divide that by n. So if I divide that by 20, that's how I get 29.85, right? And if you're like, I don't believe you, do it. Right there, okay? Now, the problem is I just got rid of my median thing, so I got to go back in there. Okay. And then my median, okay, ends up also being 29.5. So if I were to list this all out, okay, which is what you would have done, okay, remember n equals 20. So I need to know the half mark is at 10. So I could list this all out in order. I could say 19, 20, what's the next number here? 22, 23, right? And I could go right? And then I would end up with my max. It looks like I have 2 38s. And like a 37, right? And my median's still going to be here in the middle, right? I just don't have to spend all that time listing all this stuff out. It does it for me in the calculator. How nice is that, right? And then I want to know how many things are listed twice. So 37 is listed twice. 38 is listed twice. Anything else? 24 is listed twice. I don't think anything's listed 3 times, right? But this is going to have multiple modes here. Now on my 15% trimmed mean, what's 15% of 20? 3 on both sides need to get trimmed away. So I am no longer using 6 of these data points. N is now 14. Again, I took, if you're like, well, how did she do that? I took 15%, so 0.15 of my N to get that number, and that gives me the number that I need to get rid of in my data set, okay? And then you'll find the mean of those 14 points by adding that up. Now, one thing you can do, since it might be worth it, right, is go back into your list here and then just don't put those numbers in. So we're not putting in 19, we're not putting in 20, we're not putting in 22, we're not putting in one of the 37s or both of the 38s, okay? And you can just kind of create a new data list here. Okay, and you should have 14 data points there. Now just be careful when you go back to the calculate, you do have to say like, okay, now I want to use list 2. And again, I got that by doing second and then 2. You can see the little blue L2. Okay, that's where that comes from, but it will find the mean for you. 30.21. Okay, pretty close. They're both 30, right? And that's because this data set, they don't have any extremes. Okay, it doesn't really have any extremes. All right, let's look at a couple more questions here. Now, this black box magic, okay, that's happening, it doesn't give you all the data that you need, okay, especially in this next piece here. So range is maximum minus minimum. Now, we can look in this data set and you can identify, okay, here's my maximum, here's my minimum, because my data set here is pretty small. Okay, and so my range of data is 26. From the biggest value to the smallest value, those values range by 26 data points here. Now, how many data points do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So n equals 10. Now, how we calculate variance is you have to add up x minus the mean squared, and then divide that by 10. Now let's just write a couple little examples here. Now I need to find the mean, actually to do this. So if I were to do this kind of like the long way, and then I'll show you the other way too. Oh, darn it, I hate when I do that. Okay, 24. So my mean is 24.4. All right, so if I were to do this, I'm going to have 10 of these calculations. The first one's going to be 15 minus 24.4 squared. The second one's going to be 26 minus 24.4 squared, and you're going to do that 10 times. All over 10. And then whatever number you get here, you're going to take the square root of that number to get the standard deviation. Okay, now here's where I'm going to show you that your calculator is going to do some magic for you. You have to do some work, okay? You have to do some work here, but it's going to do a little bit of some magic. So let's go ahead and let's clear out our list here. So I'm going to clear out list 2 because I don't need it. Clear out list 1. And let's put this data in list 1. Oh, see, look at this. Look at that, 229. That's going to be... Okay, it might be worth just going over it and just making sure you don't do something silly. I think I'm trying to rush here in this video, so I'm getting too much. Okay, there we go. Get out of there. Run the one variable statistics here. Okay, X bar is 24.4. Done. Okay, now don't get confused. This is the sum of the squares. Okay, that's not the same as the variance. Look at the equation here. Look at the equation here, that's not that. So your calculator does not give you variance. But what it does give you is it does give you standard deviation, okay? And if you know that this is a population or a sample, that would depend on which one you choose here. We're just gonna choose the sample. So it does, or the population, sorry. It does give us standard deviation. Now let's think about this mathematically. Right? If I have something in here and I square root it, okay, to get the standard deviation, then to get the inside, I'm going to do 8.7 squared, and that's going to give me 75.69, which must be my variance. And so that's why the symbol for standard deviation is sigma, and the standard deviation for variance is sigma squared. There is that relationship between the two. And so you can kind of show some work here, and you could go down this road if that's really what you wanted to do, okay? Or you can use your one variable statistics here and kind of work backwards in order to get that. Now, the other thing that it can give you too is your maximum and your minimum. Now, again, it's not going to calculate the range for you, but it will output for you what the max and the min is. So if your data set is a little bit larger, that would be really helpful. Okay. And then your coefficient of variation is going to be sigma over n. So that's 8.7. Oh, no, it's not. Sigma over x bar. Goodness gracious. Okay. 8.7 out of 24.4. 357 or 35.7%. Okay, and if you're like, well, there's a times 100, well, that's just to make it the percent, y'all. Okay, that's just to make it the percent. All right, looking at the next problem here, this is one of those, like, it gives you the frequency table and you have to figure out all of these here. Now, I wish there was a quick and easy way to do this, and there isn't unless you have Excel. Okay, so I'm not going to spend a lot of time on this problem here. I'm going to do a couple, and then I'm just going to leave the equations up to you. These are equations that I think you need to just put on that one-pager chart, okay, and just know how to do this if you have a frequency table like this. So the first thing you would find, this is number of hours on the phone, and you just have the frequencies. So they didn't give us the full data set. So there's 14 data points. 14 data points, okay? And if you feel like there's a times 100, well, that's just to make it the percent, y'all. Okay, that's just to make it the percent. All right, looking at the next problem here, this is one of those, like, it gives you the frequency table and you have to figure out all of these here. Now, I wish there was a quick and easy way to do this, and there isn't unless you have Excel. Okay, so I'm not going to spend a lot of time on this problem here. I'm going to do a couple, and then I'm just going to leave the equations up to you. These are equations that I think you need to just put on that one-pager chart, okay, and just know how to do this if you have a frequency table like this. So the first thing you would find, this is number of hours on the phone, and you just have the frequencies. So there's 14 in between 0 and 4 hours on the phone, okay? But I don't know what they are. They could be 13 zeros and 1 4. Okay, they might be no zeros, a couple ones, a couple twos, threes, fours. Okay, I don't know what they are. I just know that 14 of them are in that bin, if that makes sense. So the first thing I'm going to do is go through and find the medians, which won't take me a lot of time. It's just the middle of my categories here, okay? And then I'm going to multiply the median times the frequency. So that's going to give me 28. 108. 250. I don't need a calculator for that one. You might I mean, that's up to you. Okay. And so on and so forth and so on and so forth. And then just remember this here. This is what you're going to want to look at for that total. That's what you'll put right there. Okay, and then over here, you're going to do m squared times f, okay? So m squared, so 2 squared times my frequency. 6 squared times my frequency. And so on and so forth, okay? So this one is going to take you a little bit of time. It might even be worth putting a little example on your one-pager somewhere where it's like, remember, this is what you do on these kind of problems if you have a frequency table like this, okay? All right, let's go ahead and look at this next problem here. So I don't know the shape of this distribution. I just know that there were some commuting times given with a mean of 34 and a standard deviation of 18 or of 8, sorry. So I need to find the minimum percentages for these intervals here. So I want to look at, like, if I have 14 to 54, 34 is in the middle. And the distance between those, which is what you need for these kind of problems, the distance between those is 20. And so K is going to tell me the number of standard deviations from the mean I am here. And I'm going to find K by doing 20 over 8. So 20 divided by 8 gives me 2.5. Okay. And then the rule says I need to do 1 over K squared to find my percent. So 1 minus 1 divided by 2.5 squared, and I get 0.84. Okay. You're going to do the exact same thing here for number 2. Now, if I want to do something similar here, but I want to find the actual interval, I want to find the 14 to 54, I want to find the 18 to 50, then I'm going to let my equation be equal to 0.89. Okay, and I'm going to solve this for K. That's 0.89 minus 1, 0.11, negative 0.11. That becomes positive. Multiply by K squared. Divide here. So 1 divided by 0.11 and I'm going to take the square root and get 3. Okay. So I want this to be 3 standard deviations for my interval here. So if I take 3 and multiply by 8, I get 24. So my interval is going to go to 34 minus 24. So from 10 to 34 plus 24, which is 58. And that's going to be my answer here. Okay. And what makes this problem hard is I don't know what the distribution looks like. So I'm just approximating these values based on this like interval rule of this 1 minus 1 over K squared rule. What's different though is if I know that my distribution is bell-shaped, then I can apply what's called the empirical rule to this data here. So here's my mean of 34, and then 1 standard deviation away, okay, is going to be 68% of the data. Okay, so 68% of the data is between, well, so if I take 34 minus 8, that's 26. 34 plus 8, that's 42. Oh, look, there's my answer to number 2. Right there, 68%. Right there. Okay. If I want to look at 2 standard deviations from the mean, so 34 minus 8, that gives me 18. 34 plus 8 gives me 50. That's 95% of my distribution is between 18 and 50, which is my answer right there. And then I already know from the first question that 10 to 58 is 3 standard deviations, okay? And so I can still apply that here. That's 3 standard deviations. What's different is when I have this bell curve, 3 standard deviations, y'all, 3 standard deviations is 99.7% of the data. Now the difference is I don't know the shape of the distribution here, so I have to use this approximation method. I know the shape of the distribution here is bell-shaped. It's a normal curve, and so I can use what's called the empirical rule to find those percentages there. All right, let's look and see if there's any other questions that I want to go over before, yes, just one more question here, and it continues through. Okay, so this question here is annual salaries in thousands. So, and there, it looks like there are again 20 here. Now I could go through and order all of the things. Okay, I could do that. And if you wanted to show a little work, you could. Like, it looks like we're starting at 38, and you could go through and you can order them all. Something that I know is that 10 has to be in each half. And since I'm going to start looking at quarters, 5 has to be in each quarter. Okay, I know that because 20 divided by 4 quarters would be 5 in each data set. Okay, it's just how spread out that data is. So I'm going to look here at my calculator, and I'm going to say, like, calculator, help me find this so I don't have to do all the numbering work. And I'm going to plug in these salaries data. Okay, for my 20 people, and it's gonna order and find all this information for me. I don't have to do that by hand if you have a calculator here, okay? So get out of there, stat, calculate the one variable statistics for me, please. Now I don't care about the mean and standard deviation right now. What I do care about, though, is this 5-number summary that it gives me right here. So Q1 it wanted me to find is 44.5, median 57.5, Q3 is 64. Now IQR is Q3 minus Q1. It is not the same as the range, it's the middle 50%. And I'll show you that in the box plot here in just a second why that's important. Okay, so I'm going to do 64 minus 44.5. And I get 19.5. Okay, and so if I were to sit here and I were to list this all out, oh look, 35 is actually the first one. So 35, 38. 39, 40. Next one's 44 and 45. I'm going to stop here. Okay, all the way up to our max of 77 here. Okay, the reason I want to stop here is I want to show you guys something. Okay, 5 data points in each quarter. So when I put them in order from least to greatest, okay, 1, 2, 3, 4, 5. This is Q1. Since it's in between two values, I have to take the average of those two values, which is why I get 44.5, because that's the middle. I got the next 5 values, okay, and my guess is that it's between 57 and 58 because of where the median lies, okay, and then I go out, same, so on and so forth and so on and so forth. Okay, and I'm guessing Q3 is probably in between the two 64s, okay, because of this here. Now 57 is going to fall in the second quartile. How do I know that? I know that because if Q1 is 44 something and the median is 57.5, well then if this is my median at 57.5, then 57 must be in that range of data between 45 and 57. Okay, so I know it has to fall in the second quartile here. Okay, now if I want to find the value at the 30th percentile, this is what we need to do. We need to figure out where the 30th percentile is. So 30th percentile times 20, okay, is the 6th data point. Okay, so I listed this out. It's 1, 2, 3, 4, 5, and 6. So it is 45. 6th term. Okay. Now on C, I am going to have to list these out and figure out where 61 is in this data set. Oh, darn. Okay. So 45 is next. Okay, looks like the next one is 50, 53, 55, 57. Perfect. Okay, that's where the median then is. Okay, and then 58, 59. This is something your calculator doesn't do this magically. Okay, 59, 61, which is what I wanted to know. Okay, all right, so 61, so there's 10 points up to the median, right? We already talked about that. There's 10 points up to the median. So if there's 10 points up to the median, and then 61 is the 11th, 12th, 13th point out of 20, then it must be at the 65th percentile. Okay, of that data. Now here's where in the homework I saw a lot of crazy things happening, and I'm going to try to do this in the next minute or so, okay? What we need to make sure we do is we make a number line first. You always make the number line first, and this is the salaries data. Now, our minimum value is 35. Our maximum value is 77. So if I start at 30, because my bottom is 35, and I increase by tens, I now have a number line that will fit my data. That's the first thing you have to do. A lot of us were just like drawing random shapes of box plots and being like, here's the labels. No, you need to make sure that you can see what the data is going to be telling you here. Okay, so it's important that you draw the number line first. Now our middle box, okay, this is 45, so here's 44.5, here's 57.5, and here's 64. Now remember, there's still 5 data points in each piece here. The reason that this box looks like it does is those 5 data points are more spread out 61, 62, 64, right? And then there's another 64 here. Okay, but these data points here are the data that they are more spread out than these ones here. You can visually see that because of the box plot. That's why it's important to show scale and have a consistent scale factor on your number line, is you need to be able to visually see what's going on, okay? Then your little whisker goes down to 35, not to your fence. Stop with the fence stuff, okay? And then to 77. This is Q1, median, Q3. Okay. And so what we can see is, I don't really think that there's overall any skew because our distance from the median to the min is pretty much the same here. So even though within the actual quartile box plot piece here, there's a little more spread in that second quartile between Q1 and the median, I don't really say that there's like a skew. Now, let's just say instead of 77, like the max was like right here, bink, 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 and there was like so much spread over here, then we would say like skewed left, right? Okay, and that's how you would know the spread there. Now, the rest of these are just example problems that look just like the ones that we just did. So I'm not going to spend video time. Also, we're way over time. So, but those are the review questions for chapter 3.